Okay, so thank you everyone for your patience. Sorry for the technical difficulty. We're going to go ahead and get started today's webinar, how to build quality-driven agentic AI in noisy big data environments. Yes, the webinar is being recorded. It should be about 30 minutes or so. If you have any questions, feel free to use the QA section to ask questions. And before I let ETL go ahead and talk, or I'll introduce ETL, and then we'll run a short poll, and then I'll hand over the keys to ETL. ETL is the Komodor co-founder and CTO. Komodor, for all of you that don't know, is the autonomous AI SRE for cloud native infrastructure. ETL has been leading our AI initiatives at Komodor for the last couple of years, and he'll definitely go into more details on that. If you haven't had a chance to hear ETL, he also hosts a podcast which comes out at least like once a month, the Kubernetes for Human podcast. Very interesting conversations that he has with leaders from across the cloud native and Kubernetes community. And yeah, lastly, ETL is obviously a big fan of Kubernetes, a lot of LLM, and follow him on LinkedIn. There's great posts that he likes to share, especially around these two topics. So the agenda, ETL is going to talk to us about how we build basically agentic AI architecture within Commodore. And before that, I'm going to run like a quick poll just to get everyone like um, into and the poll is going to launch like immediately. And I think one of the main things that we hear from both people and ETL also hosts LLM community here. But like I think one of the biggest hurdles that we hear from people is creating AI agents that they can trust in production. These are some like the things that both will be covered in the webinar today, and that we also hear from people, whether it's where they can actually like develop the agents, dealing with hallucinations, guardrails, especially for things that run in production, and also the consistency. A lot of the times we don't see like because of the way Gen AI works, consistency in answers. So I'm going to give the poll 10 more seconds, and then we'll see the results. All right. So only one person called, so I'm going to call that a small sample size, but they said that they're dealing with agent development time. Okay. So having said all that and blabbering away, I'm going to hand over the keys to ETL, and ETL will get us started.
Okay, that's good. And
Yeah, I'm going to mute myself.
yeah, so in Komodor, our mission in general is to help our customers to overcome the challenges of Kubernetes. And that means that we want to take all of those manual tasks, jobs, lack of knowledge, lack of trust that customers are experiencing with Kubernetes and simplify them in a simple, autonomous way. The problem with that is that it's quite hard to build an autonomous AI SRE, mainly because the SRE job by itself is super complicated. It's very hard to find expert in that specific domain. And to try and automate something that complicated poses quite a lot of challenges. In the call today, my goal is to talk about those challenges, how did we overcome them, and to give my 2 cents basically on building agents in a very noisy and complicated environment. So the problem, and like this is like a general problem with LLM, and also with like any kind of SRE, is that LLM really love to please users. And that means that on one hand, they are great. When I chat with Claude or with ChatGPT, I'm getting really good answers, but sometimes it hallucinates. Sometimes it lies. Sometimes instead of getting a very curated response, I'm getting things that looks like simply unreal. And that is because using the LLM without some guardrails and validation is almost like absurd when it comes to SRE production use cases. Other than that, even the best models has a very limited context window. There's the context window for agent that is like the generic context window, like 200K tokens. We observe that for complicated domains, you can't really reach that close to the context window because your LLM will start to hallucinate. Other than that, like human as well, like garbage in, garbage out, if you give your LLM a lot of like shitty data, then you're going to get very bad response in results. So you need to do a lot of job and training even before you feed the data into the LLM so he won't get lost. And in reality, like naive LLM usage tends not to work. I know that there are a couple of very cool open source projects in our domain around Kubernetes, and Kubernetes GPT is one of them. But from what we observe both in internal benchmark and in reality, those things doesn't really scale into production use cases. So for that, we built Claudia. And Claudia is, I'm going to use the term Claudia quite a lot in this like conversation, but Claudia is actually a list of families working together in order to solve complicated issues. So because everything that I just talked about in the previous slides, that Kubernetes is very complicated and the usage it needs to be very, very like tight in terms of data in, data out, and so on, we separated our AI SRE into a family of agents, right? But two different kinds of agents. One of them is more the orchestrator agent or agents. For example, the detector, its goal is to detect issues on top of Kubernetes. But this detection is not happening in the void. The detection agent can also call the subject matter expert agent. Those agents are expert in their domain. A domain might be something like GPU, it can be AWS, it can be Istio, it can be VLLM. And the same subject matter expert agent can be used by different agent flows. So on one hand, we built flows that are actual tasks that a real SRE would do. But on the other side, they're utilizing themselves. There's very small agents. Each one has its own domain. So let's say that you want to build your AI SRE, you understand the general flow of how it should look like and how we should do it. Now, what do you do, right? Like now, what should you do? I think the first thing is to understand what will be a success for you. To start with something that makes sense for you, for your users, around what is the proper way of understanding the win, basically. And for us, the key metric was and is always what would the really senior SRE do. So the first thing is that we shouldn't do any harm and we should explain ourselves. That means that like an SRE wouldn't tell you, hey, just delete all of this namespace, right? Or edit that very secret, sensitive secret. Instead, most of the SRE will like try to understand, okay, how can I make sure that I'm not going to like mess up my system instead of fixing it? Second, depth and precision. Like once we understand that we shouldn't do any harm, then we started to specialize in specific use cases. And I can say that in Komodor, for the first couple of months, the only thing that we focused was how can I solve Kubernetes pod issues in the best way possible. So think about Kubernetes, which is quite huge, right? Like it has so many moving pieces. But in Komodor, we decided to start with one single entity, which we believed is the best entity to start because it interests pretty much everyone, which is the pod. Then only after we felt confidence enough with pods, and again, it took us a couple of months, we started to add more resources. We started to add things like a deployment, like a stateful set, like a node, like a PVC, and so on. But that is only after we felt the confidence level. Now, having the right mindset is like one thing, but in reality, there are different approaches that you need to take in order to really evaluate LLM. And there's a really good, there's a really good Anthropic article that they released a couple of days ago when they talk about the Swiss cheese model, where basically, because LLM is so tricky, you can't use like one single way to evaluate it. Instead, you need to have different tactics. In Komodor, we have a combination of local development testing, gold standard benchmark, shadow agent validation, and AI-powered validation. So we have a lot of different tools, a lot of different mechanisms. Each one has its own pros and its own cons. And together, by having this full suite, we're able to confidently bring our users the relevant success, basically, which is a very accurate AI SRE. Our current success rate or accuracy is around 93, 94%. So if you can do one more. First thing first is the local development. We discovered, and I think everyone who tried developing LLM knows that LLM tends to be unreliable, unclear, and it's not that obvious what will happen once I'm going to change a prompt. So what we're a very strong believer in is local development. Have as much interesting data in your local environment or in your lab. So you can do very, very fast iteration, like the number here, 50 different iteration. I think in reality for complicated agent, it's hundreds of different iterations, which in each iteration, we might change the prompt, we might change the data engineering, we might change the tool calling. We have all of this. So in reality, once this agent is going to meet production, we are going to get very high accurate result. So first, LLM requires reality, not mocks. One of the first thing that we tried is simply have a scenario name out of memory scenario or image pullback of scenario or something like that. But LLM picked it up like that. So if you fake the data that you feed into the LLM, then what you're going to do is to get a very fake response. You need to pretty much invest a lot in how we are building those test case scenarios and your ability in general to feed very complicated scenarios into the LLM. Second, speed equals quality. Again, I don't think that there are very good ways currently in the market to build an agentic approach. It's a lot of trial and error. For doing a lot of trial and error now, you have to be very, very fast. And second is the debug with full context. That is because when things fail in your LLM, it's not clear if it's because the LLM has some hiccup, if your data engineering or pre-feeding of the data is not correct, if there was a problem with the tool calling. So you need to have all of the things that we are used to work as developers, debug and diving into a particular area. Also, when developing an LLM, it's even more acute as LLM development is more tricky. And lastly, production is to fail. It's too late. Again, I think it's true for any kind of development. But when your users know that they interact with LLM, then what they're going to get is a very bad service and distrust in this LLM if time after time it's going to lie to them and hallucinate on them. So you need to catch most of the hallucinations and most of the problems before going into production. Secondly is the golden standards. We have in Komodor right now, I think something 100 different failure scenarios. The goal is to move fast and also to have regression testing. Again, I think when you're developing an LLM, you are seeing that it becomes smarter over time. But what happens a lot of the times is that you forget that every prompt that is now trying to fix a new problem that you face might hurt the existing problems that you already solved. So again, in Komodor, we're able to capture a lot of interesting use cases, basically to simulate a lot of interesting use cases and then use this data in order to make sure that we have enough coverage when we're moving forward. So we have a regression test that help us to be safe even when we're moving in the speed and the velocity that we wanted to move. Shadow agent and experiments, it's again, it's a very fancy name for A/B testing. So because you can't really trust your LLM, you need to have multiple LLMs that are running on the same task, and only then you are really able to understand if the first one or the second one did a good job, because it's a question of context. And even as a human, when you try to evaluate an LLM call, it's quite hard. Once you have more than one sample or one or more agent that is trying to solve the same problem, you are start seeing much better and accurate evaluation, which is also critical. We have different scores for different areas of the investigation. So you can see here, we have the querying, root cause, evidence. So we give different scores to different areas in order to achieve really good and high precision. And lastly, and that also relates to the last point, LLM as a judge, because we have so much data, because there world is so flaky, we use internally LLM as a judge in order to make sure that we are capturing basically all of the different scenarios that happen in production, and the LLM that we built only for that is able to evaluate it in a safe and good manner. Last thing that I want to say here, which is a bit like it's less sexy basically, is that traditional ML also has its place. So I know that like this talk is around LLM and how can you build the best LLM in the market, but to build a really good LLM, sometimes you need to go back to like legacy approaches like ML or like normal ML. So for us, we tried for a lot of time to solve cascading failures for our customers, detect, investigate, and remediate them. And we saw that the LLM kept on failing, like we couldn't reach a good enough state. What we decided to do is to use a combination of traditional AI ML, right, to help us filtering and clustering some of the data. And on top of that, we sprinkle a bit of LLM, and the results are much better. We were able to achieve something that is very close to the precision that we're used to work in like normal RCA, but for LLMs, and that is because our hybrid approach that combines the two. So how does it look like? I think like I'll do a quick demo, right?
Yeah.
So give me 1 second, please. I'm sure, yes. So this is a Komodor test environment. Sorry, like this is the system. You're able to see all of your different cluster and overview on each cluster. And workload health is basically workloads that are currently not running as expected. I can simply click on any kind of unhealthy resource and get Cloudera response. What you can see here is a binary deployment that is unavailable because some issue. Claudia always produce what happened or how does it happen, like how did we reach to that bad state, related evidence, and like I told you, it's critical to have those sort of evidence when you are working on those kind of environments and on those kinds of use cases, as well as suggested remediation. Basically, how can I solve that particular problem, as well as a full explanation and rejected alternative remediation. In reality, it looks something very similar to this. I'm not sure how much you guys can see, but this is how this investigation process looked like, and the end result and the explanation. So we have here quite a lot of things that their goal is to help us to feel more confidence. If, for example, I go to like a workload and to an unhealthy pod, I should be able to see things that are quite similar to what I saw here. And this is how it looks like in Cloud when it started to investigate issues, when it started to investigate problems. It does everything a real human SRE would do. It asks the relevant question, basically, around that. And the goal is to be on par, basically, with the relevant steps that an SRE would take. If, for example, Cloud is doing too much steps or it fetches too much data, then it's going to get lost. Like too much data is bad. And few enough data is also not good because Cloud won't have enough data in order to operate. So we always need to find this kind of like a middle ground between the two, between having like the too much data and too little data. I see now like in a live demo, it takes us a bit longer than normal. It can happen. Again, as we are trusting an LLM, it might be a bit longer compared to like a normal investigation. And let's see what happened here. A pod out of memory, insufficient memory allocation. We have the what happened, we have suggested remediation, and I can also chat with Cloud. I think like developers are now much more used to like talking with agents than they were a year ago. So I can say, why did this happen or something like that? And hopefully the LLM will not only help me to have something which is quite like generic, it will also allow me to deep dive into that particular issue or that particular problem. And how should I solve it? And again, like the goal here is to give our customers and ourselves like everything needed in order to fix or to solve very complicated problems. Okay, so with that, I think I'll go back to the slide. But this is the evaluation graph for this session. So it went like different resources and got different results. And so I'm going to stop share this. Yeah, are they going to share again?
You see my slide?
Yeah. Yeah, so we did like a short demo, and now like just to take the main takeaways out of this session, like I think there's a hierarchy that you need to build, like trust, precision, and coverage. I really believe that in a domain like ours, it's better to be silent than to give the wrong answer. Local development, again, it's like all of the old, like I don't know, a couple of years ago, practices of how should I develop. Local is key, shifting left is key, because trial and error is your only way of building trust in the system. I think custom tools are a must. In Komodor, we spend currently like 80% of our time of adding a new agent into the system by making sure that it has the right evals, the right tests, the right tools, the right monitoring. Without that, you're going to fail. I think hybrid approach is the best way for very complicated scenarios. And also LLM can be very fun. Like even myself that like built Cloudya from the ground up, sometimes I'm like shocked with such good accuracy and such good results that it provides to our customers. Questions?
We'll open up any questions. Feel free in the next couple of seconds to ask, and we can, before we wrap up the webinar, we can try to answer. I think for Itiel, what's interesting that I've seen like our customers do is in the chat is they're not using it just for incidents. They're also using it for actual like let's call it like proactive like debugging or understanding about how their systems work. Is that also a part of how we like have how well the agentic AI understands the infrastructure?
Yeah, like Komodor Agentic learns over time. It learns the architecture, it learns the failure scenarios, and can also integrate with the knowledge base of the customer. And then it becomes a very easy to reach friend, basically, for our customers that allows to understand how our different architecture pieces are working together, what are the main hotspots that they should fix and solve, and so on.
Awesome. And I see we don't have any questions. Again, if there's any questions, feel free to reach out to us later on. Stay tuned for next month. We're going to have another very interesting webinar of managing applications that are hosted across like different environments with one of our tech leads, Mikael Alil, and that should be in late February. So stick around, so be on the lookout for that. Thank you so much, Itiel. If you, again, Itiel Shwartz on LinkedIn, you can follow him there. There's lots of interesting posts that Itiel shares and things like recently, like he mentioned Anthropic Swiss cheese and the recent article about using evals with Anthropic. So lots of interesting stuff there. And thank you so much for everyone who joined us this evening or this afternoon, wherever you are.